Okay, so today we're going to start with the product and quotient rule. So basically, if you see a product of two terms, the way you handle it here, so we have our first term and our second term. It's the first time times the derivative of the second, that's what little prime mark means there, plus the second term times the derivative of the first. So let's look at example number 1. We have h prime of x. I take the first term, we don't do anything to it, times the derivative of the second term that's sitting right here, so that'd be times 4. We're going to add that to the second term, times the derivative of the second, which is going to be, let's see, 3 minus 4x. Alright, so there's the calculus side of it. From there, we're just going to be working on the algebra, distributing, foiling, combining like terms. Over here, we get 12x minus 8x squared. Over here, we're going to get plus 15 when we FOIL, minus 20x, plus 12x, minus 16x squared. So we want to combine up our like terms. We have minus 8x squared minus 16x squared, so that's going to be minus 24x squared. Combining up our x terms here, this is going to be 24 minus 20, so it's going to be a total of 4x. Whoops, not 40, just 4x. And then, so we got this guy, and this guy, and then we have plus 15. At this point, you would factor it if you could. This is unfactorable, so this will be our final answer. Okay, so let's take a look over here. This is also a product. Our first term here is this 3x squared. Our second term is sine x. Because this is our y, our derivative, we're going to denote by dy dx. We take the first term, don't do anything to it, times the derivative of the second term. We're going to add that to the second term, which is sine x, times the derivative of the first, which is 6x. So from here, we're just going to go ahead and, let's see, I'm just going to take the parentheses down so I can see this a little bit better. This is somewhat factorable. We can take out a 3x. So dy dx is going to be 3x, leaving us with x cosine x plus 2 sine x. Okay, great. All right, so let's look at example 3 and example 4. We have a product rule taking place over here, and then just followed by like a sum and difference type situation. So this is going to look like, let's see, dy dt, because the net variable we're working with is t here. We take the first term, times the derivative of the second, which is negative sine t, plus the second term, which is cosine t, times the derivative of the first term, which is just plain old 2. Over here, we're going to get minus 2 cosine t. So just kind of looking what we've got here. Let's see, let me bring this negative out. So minus 2t sine t plus 2 cosine t minus 2 cosine t. All right, so these guys are going to cancel each other out, and so what we're left with here is dy dt is equal to negative 2t sine t for our final derivative answer. Number 4, this is just going to be a little bit more algebra because we've got 3 terms sitting there, but the process is for sure exactly the same. F prime of x, we take the first term times the derivative of the second term, which is 6x squared. We're going to add that to the second term, we don't do anything to it, times the derivative of the first term, so it's going to be minus 20x minus 7. All right, so there's the calculus again. For here, we're going to distribute and FOIL and see what we can combine up. So we're going to wind up here with negative 60x to the 4th minus 42x cubed plus 54x squared. Numbers are a little big. There's nothing that we can't handle. Over here we're going to have minus 40x to the 4th Over here, we're going to get minus 14x cubed. Over here, we'll get minus 80x. And then minus 28. All right, so what we're looking to do is combine up any kind of like terms at this point. So we have the fourth powers, so it's going to be minus 100 x to the fourth. Combining up the cubes, we get a total of minus 56 x cubed. There's just the 1x squared term, the 1x term, and the constant. Looking at these, I see that I can take out a 2. So again, you do want to factor if you can. That is going to be a requirement. So f prime of x, I'm going to take out a negative 2. That's going to leave me with 50x to the fourth plus 23x cubed minus 27x squared plus 40 plus 14 for our final answer. All right, so that's the product rule. We also have a quotient rule. So that's what we do when we have a division that we need to handle to get the derivative. In math terms, it looks like this piece over here, but you have the numerator and you have the denominator. So it's the bottom, the denominator, times the derivative of the top, again that prime means derivative, minus the top term times the derivative of the second over the bottom term squared. This will get pretty second nature to you guys. It just takes a little bit of practice at first. So let's see how this guy is going to work here. So I'm looking at this term here. We have dy dx. I can see it's definitely a product. We take the bottom term as it is, times the derivative of the top, minus. And because this is a minus, I do want you to put up those brackets and do any work behind there. The top term times the derivative of the bottom, which is this piece here, so it's going to be 2x, all of the bottom piece squared. When you're working these problems, do not feel the need to actually square this part out. We are going to distribute and combine up like terms in the numerator, though, and then see if maybe something cancels. So distributing here, we get 5x squared plus 5. I'm going to leave those brackets up until I'm done with the algebra behind them. So we're going to have 10x squared minus 4x. This is still all going to be over x squared plus 1 squared. Notice I'm carrying everything down as we go along from term to term here. So distributing and combining up like terms here, what I'm going to get, let's see, 5x minus 10x squared is going to get me minus 5x squared. A negative times a negative is going to be plus 4x plus 5 all over x squared plus 1 squared. I don't see where I can simplify that any further, so that is going to be our derivative. All right, looking at number 6, again, we have another quotient here. So this is going to be f prime of r, taking note of the variables that we're looking at. It's the bottom term times the derivative of the top, so it's going to be 20r cubed, minus, bracket, the top term, not doing anything to it, times the derivative of the second. Remember, the derivative of e is just e itself, so it's going to be e to the r power there, all over e to the r squared. All right, so we're looking at those, and let's see what we can kind of combine up. I can definitely see that each these terms has at least one e to the r. So I'm going to take those guys out of the running. So we have here 20r cubed minus 5r to the fourth all over e to the r. I'm just kind of looking to see what can be combined. If I could factor in it, I could factor this numerator a little bit. They each share a 5, and they each share at least 3 r's. So we're going to take out 5r cubed, and that's going to leave us with 4 minus r all over e to the r. And that's our derivative there. Okay, so let's flip our papers over. Sometimes it's helpful to rewrite these before we start taking derivatives. At this point, we haven't learned, well, we can do that, but it would be a little bit more difficult. I'm going to multiply by x over x, keeping a 1 equivalent. What that's going to get us here is 3x minus 1 all over x squared plus 5x. That's going to be a little bit easier to apply the quotient rule to. So we have f prime of x. It's going to be the bottom term as it is, times the derivative of the top term, which is 3, minus, again, we put that bracket up, the top term, which is 3x minus 1, times the derivative of the bottom term, which is 2x plus 5, and that's all going to be over x squared plus 5x squared. And again, with this denominator, we're not going to FOIL anything out. We're just going to keep it as it is. All right, so the calculus side is done. We're going to work on the algebra, getting things combined up. That's going to get us, let's see, 3x squared plus 15x minus, keeping that bracket up until we do the FOILing. We're going to get 6x squared plus 15x minus 2x minus 5. And again, that's still all over x squared plus 5x squared. I would recommend making sure you rewrite that each time so you don't lose it somewhere up above. Let's see if we can combine up some like terms at this point. I'm going to distribute before I do the final. So 3x squared plus 15x. I want to ensure this negative gets to each of those parts. So it's going to be minus 6x squared minus 15x plus 2x plus 5 all over x squared plus 5x squared. So in the end, combining up our like terms here, we're going to have minus 3x squared, taking care of those guys there. We have the 15x's will cancel out, leaving us with just the 2x. And then we have just the 5 all over x squared plus 5x squared. Looking at number 8, this could be rewritten as well to kind of help things out a little bit. I'm going to write this as minus 3/7 times, just taking out the fraction, the numerator part there, we have 3x minus 2x squared all over x. There's an x common to each term, so this can be simplified a little further before we even take the derivative, leaving us with 3 minus 2x. At this point here, I don't need to apply product or quotient. We are able to simplify it down enough. So what we're going to get here for g prime of x is minus 3/7. And then we're just going to take the derivative over here of minus 2, and that's going to get us 6/7. Okay, last thing I want to talk about is derivative of some trig functions. These will need to be committed to memory when you're working with these guys. We have the derivative of the tangent of x. This is just some notation here saying we're taking the derivative of tangent of x, that is secant squared. The derivative of cotangent is negative cosecant squared. If you think about your Pythagorean triples, these terms are kind of, the Pythagorean identities, these terms are kind of matching up. Secant x is secant x tangent x, and cosecant x is negative cosecant x cotangent x. You'll probably need your notes out in the beginning, but eventually you'll get pretty good at these guys. So let's take a look here. If I want to take the derivative here, it's going to be a pretty simple one. So dy dx, the derivative of x is just 1, minus the derivative of tangent x, which is just secant squared x, and we can just leave it as that. For number 12, we do have a product. We could use the product rules with these trig functions. So dy dx is going to be the first term times the derivative of the second, which is secant x tan x, plus the second term times the derivative of the first, which is just 1. At this point, I can see that they each share a secant x, so we're going to factor that out. Leaving me, let's see, with x, tan x, plus 1. And the last problem for the day, this is a quotient rule. So what we're going to do here, and we were working with sines and cosines previously. So looking at this here, we're going to have f prime of t. It's going to be the bottom times the derivative of the top, which is going to get you sine t, again, minus, and again with quotient, we like to put those brackets up, the top term, times the derivative of the bottom, which is cosine t, all over sine t squared. Okay, so looking at this, let's combine up, let's see what we've actually got here. Over here we get sine squared t. And remember in trig, the square is usually shown in between these two pieces here. It's going to be minus cosine t plus cosine squared t. So I was distributing the negative and the cosine t all at the same time, all over sine squared t. I do remember back from our trig, sine squared plus cosine squared is equal to 1. So our final answer here is going to be 1 minus cosine t all over sine squared t. And that concludes our lesson on product and quotient rule.